I'm here with the NASA Seas group that I met at AGU, working on the EarthLens project. I'll save that for you to tell us all about what EarthLens is and what you did and all that. But with that being said, I'm going to ask you to introduce yourself, where you're from. Again, just the city is fine. Uh, and your role in the EarthLens project. Okay. And I'm just going to go in order from how I see it in my screen over here, from right to left. Okay. And so first up, I have Sam.
Yeah, hi. I'm Sam Bawden. I'm from Washington, D.C. area. Um, I'm going to Dartmouth next year. I'm going to be a freshman there. Um, and my main responsibilities within the EarthLens team was essentially doing a lot of the background research for essentially identifying the problem we were seeking to solve, which was improving um, citizen science tools for land cover. So we were interns in a program this past summer, which I'm sure we'll talk about. And a lot of the tools we used were challenging, didn't give great data. And so, kind of assessing what those challenges were and then how to solve them with EarthLens was kind of where I came in.
And next up, I have Neve.
Yeah, so I'm Neeve. I'm from the Bay Area in California, about like 20 minutes out of San Francisco. And my main role within the EarthLens project was sort of helping design and plan out the drone, as well as designing how our entire system would kind of be integrated with the computational part.
Next up, I have Nandani.
Hi, I'm Nandini. I'm from Long Island, New York. My role on the EarthLens team was a hardware lead. So I did the physical construction of the drone and the Stella integration, and will be continuing to work on various iterations of the drone.
And last but not least, Jordan.
Hi, my name is Jordan Rodriguez, and I'm from Westlake, Texas. And on the EarthLens project, I focused on software and data architecture. My role involved designing how observation data is captured from the drone and transmitted to the actual app.
First off, I want to understand what NASA sees is and how, folks from all across the country got to get together and work on a project. So, can you tell me just a little bit more about NASA sees and how that happened?
Sure. I'd love to take that question. So NASA sees is really was a gift of a program, I think, for a lot of us. They do um, all kinds of programming for high school students interested in engineering and earth and space sciences and physics. And so students from all over the country, every corner, this group is representative of that, but not in the least limited to how many places people came from, including, territories like Puerto Rico and things like that. People from all over the country got together and worked on a lot of really cool projects. Ours specifically was about essentially assessing the agreement between ground truth land cover data and satellite derived land cover data. But there were groups who worked on designing future missions to moons of Jupiter and Saturn, or other really, just crazy cool things like that. And so I think it was a really awesome way to get introduced to, kind of what careers in STEM look like. And I think I speak for everybody when I say it really encouraged us to pursue this kind of work in the future.
Awesome, awesome. That's fantastic. And so we've touched on a bit of what EarthLens is, but could I bother one of you to tell me exactly what EarthLens is? What did you do for the project? Sort of just the in broad definition, a broad scope of what the project is.
Yeah, I could take this one. So, I think from a very basic, quick perspective, EarthLens, we came across the idea once we realized how a lot of times inaccurate and inefficient data collection of land cover was with the existing technology, because it relied mostly on like manual or just simply very far off inaccurate satellite data. And we wanted to change this by making it a more accurate and be more reliable because one of our friends, Jordan over here, I think he lost over 200 images that he took over like 10 plus hours. And we also had the data that a lot of the pictures that we had taken as part of our internship, they were, I believe, less than 1 megapixel in resolution. So we wanted to see how we could improve that. And we came up with the idea that a drone could address both of these problems because a drone is kind of like a happy median between the very inaccurate high up satellites and the having to go on your feet with your phone manual like NASA Globe. And with our computational parts, we can also make sure that the data can be stored very safely and we're not going to be losing it.
Okay. And so you said inaccurate satellites. What do you mean by that?
So I think very briefly, as Sam mentioned, our internship's goals was to see the difference between the land cover that we can see on the ground and what satellites are showing them to be on the main NASA data sets. And I think we can probably pull this up later sometime, but we had these large charts that we made that compared these different strips of data, and we were able to see that the data that the satellite gave about the land, specifically stuff like spectral resolutions and what was exactly being covered by that land, was often inaccurate. And it would be inaccurate in the way that, let's say, it would classify something that's grass as trees that were nearby. It wouldn't be accurate enough to see that, hey, this is a patch of like grass over here in the midst of a forest.
Sometimes even like, shadows that would be picked up, it just wouldn't give any information, or maybe it might even say it was like water because of the darkness it compared with other water bodies to those shadows. Yeah.
Tell me how this whole process sort of came together and how you all started working and collaborating together.
Sure. So the NASA Seas internship program as a whole is open to high school juniors and seniors from across the country. So we had the ability to select teams we were interested in, and we ended up getting sorted into those as we got accepted into the program. So we were part of a 50-person team called Earth System Explorers that met virtually over 2 months, June to July 2025. We had a variety of mentors, including Rusty, Peter, and all the scientists that you know. And since our main goal was to compare land cover data that we recorded using the Globe Observer application in our own community and comparing that to data existing in ArcGIS and manual data that we've classified in Collect Earth Online. We a lot of groups were deciding what to do with that data that we had generated throughout the internship, since we had like 37 different points within a 3 kilometer grid in our own communities. So a lot of people wanted to analyze the data that they had generated, but we took a closer look at our data quality itself. And then once we saw what a big issue that data quality was and how Jordan lost such a significant number of the photos that he had taken, we realized that Globe Observer had been a very valuable tool for the time that we were using it, but it had, there were challenges that were beginning to surface, especially since it hadn't been updated as frequently. And we thought we wanted to combine the benefit of the bird's eye view that a satellite gives with the increased granularity you would get just going by manually taking the photos. So we wanted to take a more unconventional hardware-based approach to doing this. And it was definitely a challenge because we're all across the country. So it was a group decision to go all in on this one leading up to AGU.
What interested you all about combining drones, remote sensing, and citizen science all together into one package?
The technologies that have become accessible to, the average person have improved greatly. I think, these Stella sensors and the ability to build a drone in your garage and access to AI tools is something that's new. And so why not take a new approach to land observation, Earth observation?
Yeah, no, that kind of hits the nail on the head. So for me, I just remember how initially we like think when we were working with our working group to see what we could take the project further with, we definitely wanted to keep citizen science in mind because that was kind of the core value that was ingrained with NASA Globe. And, working after the NASA Seas project, where we were so deeply ingrained with land cover and wanting to revolutionize that sort of sector, we decided that we had like a few different options. And I remember Jordan had this great computational idea, and Nandini brought a hardware-based idea where we had like instruments like Stella, and then we looked at each other and we were like, wait a minute, we can kind of combine both of these to make like an intelligent hardware-based system that uses this type of instrumentation to solve the problems that we need to.
What was your experience with, like, say, drone technology, remote sensing, and or the Stella instruments themselves?
Sure, I'd like to talk about that from like a hardware perspective.
Heck
I
yeah.
had never built a drone before. I actually my mechanical engineering related experience, even before the internship program, I had done a research project working on a Martian simulation chamber in my basement with a friend of mine, and that made me very familiar with that low cost optimizing, being responsible for basically every type of engineering in one project kind of experience. So from there, we were able to. I researched how I guess these kinds of drones have been built in the past. I visited my local hobby store to learn how to mount the motors right, and tried to use online resources and my own community to try to make this hardware as accurate as possible. And for example, we ourselves were not familiar with Stella tools beforehand, and I personally also had never used a spectrometer board. Actually, we started using Stella because it gave us a place to start exploring this. The very first step we took hardware-wise was ordering every part that is required for the Helio Stella and the Stella Q2 designs, attaching the circuitry, making sure it worked on the SparkFun boards that it's designed for. And then once I realized we needed to integrate that into a Raspberry Pi system to record that micro SD card and be part of the transferring to Jordan's app system. We were able to slowly strip away components like the real-time clock didn't need to be needed anymore. The of course they're slipping my mind right now, but there's displays, there's many components we were able to eliminate to make it to a more bare bones style model that hopefully any lab worker or hobbyist could build in their basement for a reasonable sum of money.
Yeah, I think
And
the cool part of it is none of us came in with any significant experience directly related to this. And I think in a cool way that's an advantage on the citizen science end of things because if we can make something that is intuitive, then it can be widely used.
Yeah, and just focusing on like, even though we were so inexperienced with hardware like this, I think one of the like beauties of science, and in specific here with Stella, was that there's like this community around people that know what they're doing. And for example, we were able to reach out to grad students all the way out in Ohio, and they were able to help us because they were like Stella experts, and we were able to use their help, and that kind of brought us forward to a stage where we wouldn't have been able to without them.
Oh
Yeah,
yeah.
and of course, it all ties back to the SEAS program, giving us this opportunity to explore what we probably wouldn't have otherwise known if it wasn't actually for the SEAS program.
Rusty connected us with two graduate students at the University of Toledo, who go by Femi and Faisal, who they work under a professor that she knew very closely. And they were both very helpful in two different ways. So, for example, Faisal was able to help verify our technical planning, while Femi was very helpful in making sure that we knew the just generally how to plan a project like this because it's such a big undertaking, and especially considering we're four high schoolers and trying to figure it out. Because I mean, in a way, we are the citizen scientists trying to put together this kind of a system. So I think having so much support on that side from not just the scientists that we directly worked with in the SEAS program, but scientists we were able to be connected to during the design process and even after.
Were there any other like major components of the EarthLens systems that you developed that you didn't previously mention?
I think, we did a lot of work specifically with how to fly the drone. With Nandini can talk more about it, but essentially, you want it to be a clean user interface, and you don't want it to be, you know, clanky controls where you have to type an input for the drone to go up or down. And so there was a lot of tinkering we had to do on that. And Nandini, if you want to talk about that.
That's cool. And that feeds right into the next question, which would be like, and I figured this go right into there. What was the sort of most challenging technical problem you had to solve, and how did you approach it? So
I gotta say, it's like I think it's the combination of all the little problems that came in along the way. Like for example, we were using this Raspberry Pi based system. We haven't used Raspberry Pis in the past. All my experiences with Arduinos. So I think understanding that the Raspberry Pi itself was going to be like a mini computer and required its own monitor and keyboard and that kind of stuff was not something I expected. So we ended up working around that so I could run it from my own computer connected to a hotspot on my phone so that it can be done literally anywhere. Because we had to do early stages before it gets fully connected to just an app. So like that's one of the challenges that came in the way. Our flight controller, for example, they come in with preloaded software sometimes, and these things are usually designed for like the first person view racing drones. And it was definitely hard to see how big a propeller, what kind of flight navigation hardware, what kind of GPS system is required for an actual observation drone. So we had to take risks like deleting the software already on that flight controller, like $150 flight controller, and hoping that I downloaded the GPS navigation appropriate software iNav correctly instead. So I think it was just the combination of, we can very clearly plan this out and go, okay, step A, step B, these are going to be all the steps that we're going to take. But there are so many little, not necessarily detours, but little bumps in the way that I guess you become more familiar with once you or a small group is responsible for the entirety of a project like that at this scale. So I think that was definitely the biggest thing to get used to.
So yeah, and you were integrating the Stella Q2 and the Heliostella spectrometers into your platform, and you also hinted at this, but what did you learn from that process, and why did you do it?
So the reason I think we chose those two in particular was that we noticed that the Globe Observer app was not just land cover, it also had a cloud cover function too, even though we ourselves hadn't used it. So we already planned to have a camera facing down and a camera facing up, which that's kind of being worked on still, with the multiplexer. But so we wanted something that was going to measure the upwards and downwards, both because you wanted to have something, comparing it to. So it's not just one data source. So like, for example, like I have the actual thing here too. We designed it using the same cables in the Stella system. I don't know if the blur can let you see it, so that we have the triad spectrometer used in the Q2 going down and giving us more channels and more informational data like we would need for that land cover observation, while we would have, I believe, 8 or 9 channels, something a smaller number of channels in the Heliostella one. And those two combined well because we were able to do the daisy chaining of sorts with the QWIIC cables. So I through the Stella system, I learned how to even do that, because if I just looked at the spectrometer board alone before that, I would be asking myself, where's the ground? Where's the ground? Where's the power? Just working in very simple, like the normal DuPont wire setup. So I think especially that Stella, the guides for Stella online helped me see how intuitive the connection, especially between these two specific ones, would be and how valuable they'd be for implementation.
Yeah, it's not just how intuitive the actual hardware is, but also just the data that it spits out. So like for our initial tests, after using the spectrometers and photos, we were literally able to create charts of our first data collections by just copy and pasting values from the output into a Google Sheet spreadsheet. So it's not so Stella the Stella devices, they served our purpose really well of wanting to get, all of the data about light in an area, not just the ground and not just the sky, but how the light and essentially mixes, or the irradiance between those two sources interact with each other, but also just how easy it is to get the data from the Stella hardware to a format where we can interpret it.
So you used basically the heliostella to help normalize the data you were getting from the surface reflectance and all that. Okay. So sort of instantaneous reflectance. So you just bypassed the whole irradiance problem itself. Now, I'm sure you have quite a bit of uncertainty with those because those are not the most sophisticated sensors ever. Are you taking a look into those into the uncertainties as well? So
Yeah, there was a certain amount of normalization we had to do. Um, for example, the wavelengths that each of light that each of the two spectrometers collect are not exactly the same.
mhm.
They're only off by a little bit, which means in a graph, we can pretty accurately compare them. But there is that small contingency you have to deal with. And then, like you said, we're not working with, massive, super accurate spectrometers. So it really is the other thing that we're working on with the drone is how we can collect the maximum amount of metadata,
Mhm.
how high we are, how fast we're moving, temperature, time, date, and all of those things combined kind of account for anything that might not make sense. And so you get a much better picture by using the other piece of data that the drone itself collects to get a better picture of what the Stella spectrometers are seeing as well.
Yeah,
And
and one of our like further works that we've planned out as well is kind of integrating an AI model into our system. And what this could do is make use of all of that metadata as well as the raw spectral data that we have to kind of eliminate as much as possible those uncertainties.
can you tell me what was involved in developing your AI classification system?
Yeah, so I can go ahead and take lead on that. So when it comes to the AI classification, we're kind of talking more about the software side, right? So
Mhm.
um, we're going through the route of making the app. So EarthLens is going to be an app that works with the sensors and cameras to look at land in real time. Basically, it'll take the information like the vegetation, soil, and water, and then it will use AI to give you like the insights right away. So when we were using the globe observer, we had to use like these little scales, and we had to kind of like guesstimate what percentage of the photo was, let's say, water or tree or shadow or grass and whatnot. So instead of waiting to process all that data later, you can see it right when it happens, right? I really wanted it to be easy to use. So you don't have to like be a scientist or an engineer to understand what's going on. Of course, that's kind of the main point of citizen science. So it's meant to work in different places too, whenever it's farmland or wetlands or even urban areas, so that the app can adapt to different environments. The coolest part is seeing the data like actually turn into something useful, right? So I've learned a lot about how the softwares and the sensors and the AI can work together. Of course, it's still in the development preliminary stages, right? Because it's not super easy to do that, but also figuring out what's realistic for a tool like this and what it can actually do, and what's better to simplify, right? So it's been a fun challenge to make something that's powerful, but also very useful for citizen science.
Yeah. And, developing an AI tool is, it's more doable than ever, but it really is a kind of a space that AI hasn't fully impacted, I think, in the way that it could. And so, all of the challenges that come along with training a model, validating data to train it on, is probably one of the biggest challenges we'll end up having to face throughout the course of this project. But we think it's very much worth it for the end goal. So that's one of the things that we're excited to work on in the future.
Yeah, and while we're on the topic of both challenges and I think it's really important to note that one of our main goals was to also keep the whole thing really affordable. And that means making sure that all the computational power that it would take is kept to as little as possible. So we have to sort of balance how heavy of an AI model we can use without having to make sure that, oh, there has to be like a big fat computer on board the drone or something.
What particular, say, NASA missions would you be comparing the data to, if you are you comparing the data to, if any?
I believe right now, in our Adopt a Pixel, in the Adopt a Pixel methodology, like chart that we've been using so far in this internship, I think we compare Landsat and Sentinel data specifically to what we've observed in Globe. And I remember in our poster, we proposed adding an additional column with the photos from down, another one for the up photo, and then like ones for those graphs individually. So it could be seen as like an expansion to the currently existing like comparisons that are being done to Landsat and Sentinel data so far.
I was gonna say I completely agree that we had a few conversations with people at the HU conference that brought up similar topics about kind of thinking about how Earthlands itself could expand to slightly more than just land cover observations, and I think that integrates nicely, comparing a lot of different sources of satellite data, and also it sounds like Stella has a few more really cool tools that we could work with.
Can you tell me directly how did you divide responsibilities among your team members, and what was your specific contribution? So you can go one at a time if you don't mind. And Sam, since you're already like on screen, or at least you're in my widest view here, go ahead and start with yourself if you don't
Yeah.
mind.
Yeah, so before this project, I really can't say I had that much technical experience. I've learned a lot throughout this project. I do have some pretty significant experience working with the Smithsonian and the communication of science. And so a lot of what I contributed to this on this project was um, kind of how to talk about how we are kind of converting from globe to what we think could be a better system. Um, and then also kind of trying to optimize for citizen science. Sometimes, when you have these grand ideas for projects, it's easy to let them slip away from you or become much bigger or more expensive than you really have the capacity for or than what's even intended. And so I have found a lot of joy in um, helping to kind of stay on track towards a citizen science goal. Um, I think in terms of division of labor, like we were talking about earlier, I definitely had limited technical experience. Nandini has had a good amount, but none of us have had an exorbitant amount of technical experience. And so we kind of just fell where our interests lied. And it's a small team, so everybody gets a bit of a little bit of everything anyway. But we've all have our unique passions and have worked hard to integrate those into the project overall.
Fantastic. Neve?
Yeah, so as Sam mentioned, like I was kind of going into that little bit of everything type of flavor. So I personally have experience with both the hardware and mechanical engineering as well as software, and specifically in how like both of them can be integrated. So I helped sort of design and plan how and what the drone could do, as well as how we would integrate that with some specific systems that our AI and the software models could use to make sure that the entire system solves the problems that we want to, while making sure that everything's reliable and affordable.
Fantastic. Nandini?
Yeah, so I definitely agree with Sam and Neve talking about how we kind of did go where our interests lay. In the very beginning, we started our working group as actually about a 10-person group. And the very first thing that I had us do so that we could get some progress in deciding what projects we would do was, introduce ourselves and introduce what we liked to do in a technical standpoint. So we had a literal Google document with a list of all that and all the ideas. And that's kind of how we split which people went to do EarthLens, which people went to do a different AI-based project and that kind of stuff. I would say in terms division of labor. I always liked the hands-on building component the most. I mean, I'm grateful my parents have allowed me to take over about half my basement and build, I guess, whatever I need. I used to do a lot more art down there, but I ended up switching it into more of a little basement lab setup. So, and you know, I want to go into mechanical engineering. The physical hands-on stuff is my favorite part of it. So that's why I decided to build the drone itself. And also, like, I have familiarity with being up at like 2 or 3 in the morning and saying, guys, this thing's finally works. So I'm sure Sam, Jordan, and Neeve remember the every so often like a 1 or 2 minute video of like demonstrating something working and that kind of stuff. So I mean, I feel like I fell
It
where
would be the
my I
highlights of
felt
my
where my
day.
interest was. I'm very happy to hear that.
That's
So yeah.
fantastic. And then Jordan?
Yeah, so before EarthLens, right? I also have to say, Nandini, yes, I did love watching those videos. But before working on EarthLens, you know, I also didn't have much hands-on experience with a project at this caliber. So I know I had done some programming and but of course, again, it was never at the extent that we did it with this project with EarthLens, right? So specifically, my role in EarthLens was really focused on the application itself. So I worked in designing how the app processes data from the sensors and the cameras, and you know, turns it into real-time insights about land cover. Of course, going back to things like vegetation and soil and water. We also tested a lot of troubleshooting to make sure the system was reliable and accurate. So yeah, I have to say, I think the thing we're most proud of was how we all grew in the process. So from almost no experience to a project that caught a lot of attention at that conference, right? It taught us, you know, how to build from nothing to making such. We took a big stride, I have to say.
What do you think Globe added to the project?
I'd honestly say without Globe, there is no project because that's what really gave us the foundation of what already exists and what we want to improve upon. And from that introductory sense, I think Globe is phenomenal in what it does. It's a very accessible technology. And what it means to do is to get the scientists, if like to get citizen scientists activated and mobilized in a way to give our actual professional scientists the data that they need. And what we just saw was the opportunity to make that whole system better, more optimized, and that is in no way as they saying that Globe is not doing what it was meant to do.
Yeah, and I also have to say, you know, science isn't science without problems, right? So of course, using the globe, it was a really strong introduction to remote sensing. I personally had no idea what remote sensing was. And then of course, we got into the SEAS program. We got accepted into the Earth Systems Explorers, and they taught us about, you know, the Globe app and working with the Globe app taught us, you know, to collect consistent and accurate data. And of course, speaking from my experience, doing all that data aggregation and all that, it took close to 8 hours in total. And then I took all my photos and I was praying that they all, you know, saved to the database. It was 216 photos I took. I lost 202 with the Globe Observer app. But of course, it is phenomenal at what it does. But it was just a little bit of a misstep.
Gotcha.
Yeah, and it you know, it got your hands dirty. You had to go out and do the field work, and you had to do the ground truthing, and it was a messy process of how to, you know, compare what you're seeing versus what sensors orbiting the Earth are telling you. And it's great at, you know, highlighting that friction. Um, we just think, you know, there's a system that could improve upon what Globe has already been able to do for citizen scientists that we can pursue.
Are there any other skills that you would like to mention that you developed through the project that you haven't already mentioned?
I'd say personally for me, one of the main soft skills that we were able to build was definitely like working with a team. I think this was a big emphasis that our mentors at the Seas internship had given us, and they've given us resources like that one team building module and how to do research in teams. And I feel like it was definitely really important for us being spread all across the country. But the fact that we were still able to be so productive and have that sort of bond and that connection between us to make sure that we were all on the same page. Those videos that Nandini was sending, like that's the type of stuff that makes us all know what's going on, be like happy with what's going on, and make sure that we're all communicating perfectly.
Yeah, and I'd say also the skill to take what's happening internally in our team and be able to communicate that externally. So from, you know, Nandini building the drone and Jordan building the app and us all collaborating on, how to quantify results from the research we did with Globe and comparing what the drone gives us. Like that's all the technical stuff that goes on inside, and then being able to put that all down on a poster and an abstract or in a paper and put that out into the world for people to get an idea of what we're working on is it's a lot of abstraction. Um, and that is a skill that we've definitely developed through this project.
How do you see EarthLens being used, say, for agricultural monitoring or environmental research? How would you like to see it used as well?
I mean, I would say the way I envision EarthLens, especially in these earlier stages right now, is we plan to put together, I've started drafting this, a guide similar to inspired by the Stella guide of components of how to build each one of these drone systems and all that kind of stuff. I mean, now since AGU, we've started communicating more with researchers across the country who've expressed interest in it. And we hope by getting it into a larger audience like that, continuing that integration with Stella, we could have it be something that a hobbyist or classroom or that kind of stuff, people could actually start building these and using them in their own communities, kind of like how we use Globe. But I think the other benefit of it being a drone is that as we adapt it to be able to fly higher and have a bigger field of view, it'll be useful for maybe if there needs to be a weekly observation of certain fields or agriculture areas, like you were saying with the coasts earlier and that kind of stuff. I think it could be useful starting from this research perspective and continuing from seeing like environmental stability and things like that. So
Yeah,
yeah,
and
pretty much that.
just just to add to that, you hit on the agricultural piece a bit, but the sheer advances in technology that have occurred in agriculture over the last few decades are amazing, and it's what allows us to feed the modern population of the earth and a growing population of the earth. That's really important, and technology is one of the main ways we're going to be able to continue to do that. The way I envision EarthLens kind of being able to do that is right now you can survey your land to an extent, and you can use the satellite data that's made available to farmers to inform the parts of land that tractors go over to fertilize or the different seeds that are planted on different portions of land. And those are all based on satellite data as it is now. And in the research we did in the SEAS program comparing ground data to satellite derived data, we saw that there are inaccuracies in that. Seasonal inaccuracies, spatial inaccuracies, temporal inaccuracies, and if you have something like EarthLens that's small, that's modular, that's easily deployable, that's personalized and easy to use, but that still turns out quality data more immediately. You can, imagine a farmer launching a few EarthLens drones and having them fly over their field, like Nandini said, once or twice a week, and get maybe even a more detailed image of their land than they would from modern satellite data. And so I really like this question about how to use EarthLens or similar technologies in agriculture.
Building off of that, have you played around with any vegetation indices since you've been doing, or at least thinking about like plants and agriculture and land use and all that?
We're not fully there yet right now for this first iteration. Right now,
Hmm.
I mean, right now we're working on more mechanical challenges. Like, for
Gotcha.
example, a big thing is that the LiPo battery, for example, to power this is pretty heavy. It's pretty heavy, and it's time. And right now, our maximum estimated flight time that we've been working towards is probably around 20 to 30 minutes a piece right now. Now we got to work towards extending that or making that battery system more interchangeable. And then in that next level, we would integrate those Stella, like the air quality systems and things like that. Thankfully, our flight controller gives us things like accelerometer and other specific motion and gyroscopic related data. But I think as we keep adding on different layers, we're going to start, maybe seeing if we can train it, like as Jordan and you were saying earlier, in the AI standpoint, towards data sets with healthier or non-healthier vegetation, knowing what to flag in an image and that kind of stuff.
Yeah, and I have to say, I really like the question when you touch base on the agricultural side. So I am from the Rio Grande Valley in Texas, and it's a region where agriculture plays a very important role. Of course, not just to the economy, but to the community as a whole. So I've seen firsthand how much farmers rely on knowledge of the land, the weather, the crop cycle to make these decisions every day. And that's, of course, where we see EarthLens making that difference because it can collect data from sensors and, cameras and processes, as Sam had explained. So, coming from the region so connected to agriculture, EarthLens has been exciting, of course, because it can really improve this agriculture that we have here in the valley.
Are you inspired by any of the different NASA missions and Earth science that you've, sort of probed at, and then which ones have you really taken a look at? Is it just Landsat, or are there others out there as well? And if you are doing Landsat, what might have inspired you with Landsat as well? So go ahead.
Yeah. So we've worked with quite a few different earth science projects. I think from the original data sets we were comparing our ground truth data to, we were pulling from Landsat, we were pulling from um, a few different data sets with Dynamic World and ESRI and World Cover and um, a few different tree canopy data sets. Um, and then we also, again, we worked with Landsat time series data, which was cool to interact with. For me personally, I wouldn't say there's one specific earth science project that I've been, singularly inspired by that we did hear from one of the main engineers who's working on the NISAR mission, which is a very newly launched telescope that uses some really cool technologies to get information we've never seen before. But I think in when you take them all together and you get, a more complete image of Earth systems and science on Earth, that's kind of the part that truly has inspired me. Um, the goal of NASA to continue that kind of research, I personally feel is very valuable, and so that's kind of what's inspired me throughout all of this.
For right now, right now at least existing, the only thing we're comparing our global observer data to is that kind of Landsat and Sentinel data. And as things continue to change, I mean, having satellites that is in the hand of labs on their own or hobbyists and that kind of stuff, still being able to contribute to some sort of shared thing, maybe like an ArcGIS layer or something like that, gives us, another thing to verify against. And I think that's definitely a motivating factor to keep using that in conjunction with the satellites while we can, and allowing that to be a technology that continues to evolve alongside it.
What would you like to develop further if you could continue this project? And do you have plans to?
Yeah, so I'd say on top of like that whole AI and automatic classification goals that we have, where we wouldn't have to manually classify each pixel of the data that our drone takes, the AI would take care of that. On top of that, we also have an idea of perhaps adding intelligence to the flight patterns of the drone. So in a way, making it an automated flight, which would make the entire system a lot more efficient and make it easier for people like average Joes to be able to use the entire system. And I'd say as EarthLens as a whole like scales up, there's a lot of potential for it to integrate with external platforms that already provide data sets and have this sort of connected infrastructure, which would just make the data that EarthLens gets and people using EarthLens have been taking and putting it out there for a lot more people to use and having a lot more eyes on that same data.
Yeah, I definitely think that's a very great way to keep progressing it. And I think from the hardware perspective, I think, like I was saying before, integrating that carbon dioxide a sensor and integrating some of the things that are being added in some of the new Stella variations would be something that we plan on implementing back in the drone. And automating flight patterns is actually the reason why we switched to that iNav flight software, so that it's the easiest way to go about that in the future. So I think it's definitely good that we're starting to explore these possibilities of what we're going to do in the future now, so that we can kind of make those steps as easy as possible, like starting from where we are today. But we definitely all have plans to keep continuing this project, at least for the next couple of years and that kind of stuff, because now we see how valuable a continually updating or continually improving application or system like this can be. So,
Yeah. And Nandini and Neeve kind of tapped on it, but earlier, but the end goal is the citizen science access. And the whole point of making tools available for average people to collect scientific data is to make that data available to researchers who, will know what to do with it, know how to draw conclusions. And so we hope to also continue work with EarthLens in terms of how to get that data out to researchers and how to allow um, users of EarthLens to make their data accessible. The app is the main way we want to do that, but also we hope to maybe one day have enough data to make a meaningful um, uh, geographic data layer on a software like ArcGIS or something like that.
How has this experience influenced your career interests or academic plans?
So, uh, like I said earlier, the C's program, was my first real kind of technical and scientific experience. And I definitely want to continue that. Um, I want to study engineering in college, and I think I'm going to try and continue with that. I'm planning on going to a school that allows you to do a lot of interdisciplinary study, and being involved in EarthLens has also um, generated a lot more curiosity for me about earth science and kind of the associated technologies in space that help us conduct earth science. So I'm really excited to continue in that sort of direction.
Yeah, for me, I'd say the process of developing EarthLens and the Seas internship as a whole, it's kind of made me firm that I want to keep being like this sort of inventor. I'd say the fact that we were able to design and create something that didn't exist before, and it's like completely our brainchild is so cool. And that kind of motivates me to keep on doing that sort of tinkering, that sort of problem solving, and especially in this like using this interdisciplinary nature, but making sure that we're grounded in solving a real world environmental issue is really beautiful.
yeah, I would say for me, it's made me more solid in my decision to pursue mechanical engineering for my undergraduate degree. But because I've had such a wonderful time integrating this building with so many different other aspects of it. And like Sam, I mean, I think it's made me a much more interdisciplinary builder, considering my prior experience is more aerospace connected. I think that exploring earth science and more applications here, it's made me more willing to explore all different things under NASA and scientific purview. And I mean, I plan to continue studying, hopefully, in grad school in either aerospace or nuclear engineering. And I feel that EarthLens and this experience in earth science has given me the willingness to keep exploring in that regard, and keep seeing which type of engineering I guess calls to me at that point.
Yeah, so I totally agree with what everyone else has said. I am a junior, so I still have, a year to think about, at least a year to think about it, but not a lot of time, right? But working on EarthLens, through NASA Seas, really shaped my interest in what I do want to become, and that is aerospace engineer. So before this, I hadn't, of course, I have already said, I hadn't had much experience with projects at this scale. And, Seas exposed me to that, the real world engineering challenges, such as, collecting, aggregation, and analyzing complex environmental data, designing systems to process that data efficiently too, and making decisions based on the real insights, right? So I think the experience also taught me how to approach problems with a method, right? So to adapt things that didn't go as planned, and to think critically about, how technology can be applied to solve big real world problems, right? So participating in C's influenced my goal of going to UT as well, UT Austin. It made me realize what I want to be in an environment where I can work, with great ambitions, impactful projects, and continuing to grow as a thinker and, of course, a problem solver.
What was the most rewarding aspect of working on this project? Like what do you hope people take away from learning about EarthLens, and is there basically anything else about the project that you'd like to know? So, uh, some sort of combination of those three.
I think, these have been pretty comprehensive questions. We've talked a lot about what EarthLens is for and how we hope it gets used. If God forbid the project never gets finished, or if you never get your hands on an EarthLens drone, um, the thing I would hope that people learning about it take away is just that um, these things don't have to be stagnant. The way we study Earth can evolve with technology. Um, and I think it should, because we have better ways to collect data, better ways to interpret that data, better pipelines for that data, and more data. And all of that in together just means we get a better picture of our Earth, how it's changing. There's a lot of ways that influences policy, economics, um, and you know, just in general, we hope EarthLens gets people excited about studying the Earth for change.
Yeah, I'm 100% agree with that. And I would say I think a big thing that I guess anyone, especially maybe high schoolers or college students or people newer to these kinds of things can, I guess, learn is that, I mean, we all came with relatively small amounts of experience in here and kind of used whatever we learned through this internship program to formulate this kind of mission. And it felt nice to kind of, I guess, like as Neve said, to be a group of, inventors in this regard and something we weren't as familiar with. So I think it hopefully should encourage to keep learning and I guess keep tinkering about this kind of stuff, considering, I mean, you can build a drone that can do these kinds of things in your own basement. There is more capability to do these kinds of things outside of the traditional laboratory or an environment that's typically seen for more professionals or more for adults.
Yeah, I'd say personally for me, touching on like that most rewarding part, I'd say some of the most rewarding like emotions that I felt were when we were all on call and we'd be throwing out different ideas, and then as soon as we'd hear one, then we'd think of one that stuck. It'd be so rewarding just to feel like, hey, I can see this, I can envision this actually coming into existence. And I'd say one of the beauties of like the whole process of EarthLens in general is that in a way it has like endless possibilities, right? Like so far how we've thought about it, we have like a few different ideas that, oh, it can go into use here, it can go into use there. But at the end of the day, we're still high schoolers, and that's one of the goals we have with reaching out to experts in the area like Michael Taylor, like people at NASA, at like people over in different universities, because they're going to give us so many new insights about where we could take this, what we could add, and how we could keep building.
And for me personally, right, I think the most rewarding experience of working on this project was seeing how what we could develop can actually make a difference. And again, reiterating, we're all just high school students, right? I mean, we made this project from scraps, right? So one thing that really excited me, of course, was also the power of citizen science and how a tool like this project can let anyone contribute to, collecting data and understanding environmental data. So it's amazing. I think that this project could really connect communities, students and researchers across the country. In terms of goals for EarthLens, I really hope it continues to expand. I think we all really think we're just gonna, keep driving, right? Of course, we're from literally all four corners of the United States, right? So sometimes there's a little bit of a challenge in getting communications, but we work it out with our time zones and stuff like that, right? But I also wanted to take a moment to thank NASA Seas, right? And of course, you, Michael Taylor, for allowing us to present this project. Yeah, it's been an amazing opportunity. Being part of that program was a huge learning experience, and it inspired all of us to keep exploring, right? Building and contributing to projects that, have meaningful real world applications.